Добрый день. Снова здравствуйте. Я переместилась.
Hello, once again. I moved here, and right now we're going to continue talking about informational security, about technologies in different industries,
И
and
сейчас
a lot of interesting things await for us. And we will speak about highly precise informational security
программно-аппаратные средства.
and how we protect hardware software by industrial automation.
Догадаться, в кадре виден Владимир Назаров,
We see
руководитель
Vladimir
отдела
Nazarov, the head of the Department of the Security of Industrial System. In positive technologies, when he comes, he always speaks about SCADA and Sergei Safonov, first Deputy General Director of Moscow plant FISPRIBOR. Hello. For you, viewers will open a secret with FISPRIBOR. We are friends in course of many years. Yes, many years. And those of you who will join us in May, we hope and we plan to have a joint partnership project. Two new cells will be in our cities. And you've been celebrating. One is size of you, another size of me. Well, they had to be installed where you and me are located. Yeah, from the side of the energy. We're planning them. Yeah, we will be able to do that by that time. So I've crossed my fingers. I hope and I would like to see how this will look like. And you didn't speak about the most important thing, the nuclear energy and nuclear. Well, the key words in the cross-section of what are we going to communicate about. Together with FISPRIBOR, we've been planning to do it for this event, but everything has technically moved. Once again, we would like to reproduce systems of management of the development of, together with Sergei Ivanovich and his colleagues. How many? We have two complexes, right, Sergei? Preliminary, two of them. One at the hard logic and another one on PLCs, on the line of PLCs. You're telling us details so that guys would get ready in the course of 6 months. Yes, as always. It is very important to get ready for this. We also have certain objectives which are not related with this topic, and at the same time, this is related with a new PLC product line that has to be prepared for this event. New and fresh product line. Well, this is a story that, colleagues on hard logic devices we've been looking at, and right now the whole world moves digital, and this is a global trend, and I'm not going to stop you. I will give the floor to Sergei Ivanovich. Why it happens like that? Well, I would like to go to the final question. How did we go from digital logic, hard logic, and when do you plan to go digital? When will this happen, the balance between analog and digital? Well, at the current moment of time, we are not planning to leave the hard logic. You're not planning. No. Is it an extension of possibilities? Why? Why? Well, first of all, we have achieved in hard logic a very good combination of its diagnosability and minimization of their sizes. This was the main criteria of the replacement of digital equipment, hard logic, so that if the digital is one shelf, if digital logic it's 10 shelves. And because of this, it seemed like it was, making the system more expensive. But honestly speaking, right now, the density of technical means and hard logic is not significantly behind the programmable equipment. Previously, it was like 1 to 10, but right now, it's like 1 to 1. Everything depends on which technological algorithms will be utilized. And projectants will give us some objectives. Yes, objectives. You are not going to deny the hard logic, and one of the systems will be on a hard logic, and all the remaining one there will be new solutions on the program components, digital ones, and in parallel they work with the systems. The hard logic is also in its composition. It has a certain programmable part to it, and as a rule, it is related to diagnostics, and in addition to that, it's a transfer of informational signals to the top level. So, in other words, this is in a SCADA system. for the operator, as I understand? Well, I understand. As for the management, as for the control in a hard logic, it is absent on the top. Well, I have a question for me and Julia. I would interpret this as a very good positive news. Why? Because some channels are still in hardware solutions, hard logic, and from the point of view of us as people who are interested in, well, so that hackers, well, maybe I said it wrong, so the technical capabilities of this thing at hard logic, it removes the capabilities for hackers to do something. So when we've been searching and researching their systems, we came to the conclusion that hackers in these diagnostical channels, they can interfere and influence, but this, basically speaking, doesn't give, in B20 ideology, it doesn't give those possibilities to stop this technical process, this station, and stop production of electrical energy. Well, the hard logic does not allow them to do that. So the station which generates electrical energy, this is ideal capabilities for attackers. Okay, that's absolutely true. And, you know, the colleagues are switching to digital technologies, basically speaking from our point of view, while they still have those things on hard logic. This is good and this is safe for all of us, for people living on this planet where these power plants are working. Do I say it properly? Well, hard logic, that's why it was created, so that it excludes influence from the side of the operator, the influence from the side of certain digital networks into technological processes. It's impossible to interfere there. Yes, you can try to change information which is transferred to the top level, but for this it is not necessary to knock in the system, because the information is being transferred to SCADA, to the top level, and it can be replaced even on that level as well. But from this point of view, this is for the operator. However, the operator, when he looks after the process, he is not following 2-3 signals which are coming from one subsystem. He evaluates situation generally, because these can be, well, if it works, it works. This equipment has a property of having some deficiencies. It can break. But can we replace an operator by artificial intelligence? I think that in critical informational infrastructure objects, it will not be possible. The person should be available there. While the person is more precise, or the person will play a function of this second level, second controlling board. Well, routine objectives are automated and equipment have replaced people, but people should have leverages of control. They should stop, they should launch, and only the person makes the decision what is to be done. And these routine operations have been automated already, and everything which is related to artificial intelligence, this is being produced by people. And this is even the most complicated computer on the earth. This is a human brain. This is the most complicated computer, and the one who knows how to make in non-standard decisions in non-standard situations. And this is what is required at any facilities like that. Sometimes we need to make non-standard decisions. Well, from your mouth, it sounds very reliable, safe, and very cool. This is not true. Well, I have a question. If everything is like that, if everything is so cool and secure, analogies are, ensuring the digital technologies, human secures everything else, and only the human decides what happens. But why in our story we have the word, my favorite word, which is called Stuxnet, where all the insurance companies were looking at, not only Stuxnets. After Stuxnets and even before the Stuxnets, there were other computer worms that were crawling in the nuclear power plant stations, and because of them, certain stoppages and shutdowns happened. And in the year 2014 in Korea, there was a very big break-in when people started posting these documents into Twitter directly from the station, how it is being produced. This is a sensitive information, and the station was shut down for a while. But it has nothing to do with emergencies, fortunately. we've noticed this. That it didn't lead to big emergencies. Nevertheless, all these together, as I've been told, that hard logic is very good, that technologies are available and people control everything, and Stuxnet and everything was built to lie, to hide from the operator, everything that happens there. Yes, it was available. And we can add to this that Stuxnet is not nuclear plant. This is one of the elements in the industry of fuel preparation. But nevertheless, it's like that. And I believe that such interferences like we've had from Stuxnet, this is not done just in vain. It's not a penetration from somewhere outside. Basically, it's a substitution of the software, but in the facility. It didn't start doing that immediately, but temporarily, on a step-by-step basis, it started changing. So in order to have a possibility of making such interference, first of all, you should know the system very well. You should know the algorithms which are solved by the system, and you should know the technology, what is to be done with it. So this is, those people who've been doing it, or those people who've been managing these people were well aware about all the processes of these centrifugal operations. I will support Sergey Ivanovich. There is not a lot of public information, but the code, which was reversed by our reverse engineers, does confirm to his words that this code was precisely made for the specific system, for specific algorithms, for configuration of those devices that were used out there. And then the same one was found at other Russian power plants. It didn't work because it was not aligned. Different hardware platform, different logic, and that's it. It didn't work. It just crawled all over the world, but it didn't work anywhere else. It's like a story from other films about biological a weapon which is aiming at a certain DNA. It will kill this guy, but nobody else. Same thing, it was aimed at one facility, and I would like to tell you from my side, in order to write things like that and make it work, you had to know precisely A, lot of technical information all the way to the projects from that particular working facility. B, you had to accumulate a stand, and there you had to create and test it and debug it to make it operational, because, even though just this information, 99.99999%, it will never work from the first time, because it's a big, complicated code. So it's a story that somebody have done a lot of preparatory work, have created a stand, and then it didn't go to the internet. Somebody physically has brought the flash card and launched it, so it was a work from within. The amount of money, costs and goals, well, nobody earned money on this. This was on the level of special services, secret services, and on the level of the state. It was sold. It was a first sample of cyber weapon, very highly precise intellectual cyber weapon. Yes, it have turned this first page in history. Well, my question, why there is no continuation to this? Well, this was a reason to do the damage, to centrifuge. Will it stop? Will it rotate? Will it break? They've done it in such a way. They just wanted to destroy. And it's not necessary to develop this process to details. You just start this process and it starts applying some micro changes which are getting accumulated, and then accident happens. Why didn't happen? Our city and our stories that we've had in 2015. Okay, your city, I'm not touching it with my hands. This is the right thing, but basically speaking, when we do something, we do it relying on what was happening. And many stories that I've been telling you, these are stories that were happening in reality. Those stories equal to Stuxnet. Yeah. Let's remember Ukraine in the end of 2015. There was a target hacker attack to disconnect the whole region. Somebody came, disconnected, and left. And, deleted all these servers. Nobody could understand whose objective was it, but nobody earned any money. You don't know that, and you will never learn that. But I have a question about complexity of the attack and complexity of influence, complexity of organization. When you are speaking about that, in my head, I have totally different sphere but complex organized attacks. For example, if I'm a criminal and I want to get inside of whatever, into a target place, but I cannot because directly I'm not connected to this target place, sometimes it's much simpler to find some trusted entity who is less protected, but out there he is trusted, and attack to this trusted entity. And right now I'm leading you to the situation that you are a supplier of software technologies, not just a supplier, we also developers. Penetrate into the target organization, to the developers. And as a developer, we do evaluate this risk, not only industrial one. More correctly, we can call it by classical term in the area of information security, the attack to the supply chain. You're a vendor, you supply something to this facility, like we've been speaking, not a direct attack against the facility, but to the supplier, because supplier has official access, he will bring and deliver it to them. Well, this is a question to the providing information security in the company, specifically in our company. For example, if we are developing the software, for this purpose, we have certain tools. Well, if we are going to develop this software through some standard means, then it's understandable we have a question, how can we protect the source code? But there is a situation why usually it works. For example, like with Stuxnet, those who do it, because any developer can say that if you do software for managing some facility and you were giving some source code which contains 100,000 of lines of code, any developer will say, I will write a new one. Then I will try to dig into this one. Well, it's a developer. He has totally different objective. But on the other side, I would like to add, our colleagues, just recently in the spring of this year, there was a project that we've been assessing the protectiveness of their solution in the framework of the consulting that we are providing. We had to look at the code that was written by them, and we should help them in this objective to the security guys. So they are thinking about it, and they do work in this direction together with us. It shows their awareness. We are solving this together with them. Well, I'm not going to speak about what you have discovered there. Well, about informational security and development of the software product, it always have existed, even prior to we have started speaking that let's try to protect critical information infrastructure. We call it differently. We have GHOST from the year 2019, which is related to the order of development of the software products. That initially, when you start its development, you should have an order for programming where you will define what is to be done there. And then there is a concept of verification. Every stage of software development should be verified. Do you develop it properly? And then afterwards, people speak less about it, information security, but basically speaking, we are speaking about what? We are speaking about some unsanctioned actions from outside, but there is something which is called non-declared possibilities. Well, this is my favorite one. Surprises. And this is what we've been doing. We have been looking at those tasks, and this is something which is related to verification. If we are looking at this legal framework documentation which describes it, technical specifications describe it, like for nuclear energy, they have their own specifications, how it's supposed to be conducted, what should you pay attention to, how this is done, what should you look at. And this is all available out there. How can we discover these non-declared possibilities in order to avoid hitting the object in the future? Or the software that has been developed, it's been checked, it's been installed, and this is not the end of the software development. This is always being checked, control sums before it's being uploaded down there. So you have a very big stack of additional checks. Yeah, this cycle is very big before the product will go into the usability. It's not like update flew in and you press the button and firmware is downloaded. No, the update of the firmware, it's a big process. It has to be verified, it has to be checked on models, it has to be checked on some experiential samples. For example, in a company, there are testing center and those samples of all those subsystems that are being delivered by us. That's why, prior to introducing any changes and transferring them to the facility, we're checking them here. So internally, I understand you have your own range. We have our own storage system for the software documentation. And when we went to our colleagues, to their factory, we've seen they have a big workshop, everything works. Yes, and we have excluded the possibility for the developers when they develop the software. They do not install it into technical means. For this, we have totally different department and different people. So this person should post it into a certain location, compiled code. This code will be tested, checked for operability, and only then it will be downloaded and complex integrational tests will be conducted, and after this will go to the object, and in the object they will have the complex of testing from autonomous tests, then complex tests, and only then which period of time from the development to the beginning of facility work. It's a tough question. I've learned about numbers which they have in nuclear energy. Well, saying that nuclear plants are built in the course of 5-7 years. Can you imagine the cycle of development of the software and those systems that we are in building? They're related to long cycle of production systems. And this extended cycle of passing through all these procedures. I never had anything like this, and when I come to the colleagues, which period, they say, well, we have 5 days, 5 years ahead of us. We usually have 5 days. It has to be done yesterday, day before yesterday, but they have like 5 years. So we always have this interesting moment from the point of view of working with technical means, and this is related to everybody. When you are doing development, when you check and test on the field, and then you come to the facility and everything has changed and everything is completely different. Yes, this is a problem. And in this period, everything have changed like 5 times. So to us, this is not an empty sound. This is something that we call electromagnetic compatibility. This is also important. And those electromagnetic fields that surround us and that influence all these communications, they also influence, and sometimes we have to understand whether it's related to the software or maybe it's a hardware problem. Honestly speaking, both of you have disclosed a new layer of knowledge, totally different one. Yeah, you gave me a tip for May. I will wait for May, and I'm happy to hear. And, you know, the residual knowledge that stays inside of me, it's certain piece that everything's okay, everything's gonna be all right. And I'm happy because usually when I talk to other people in the studio, I leave the studio and I think, oh my God, maybe tomorrow everybody's going to die. But, well, nobody's dying. Everybody's going to stay alive here. In my studio, I've had Sergei Safonov, first deputy CEO of Moscow Fizpribor factory. I hope to see you in 6 months in May. Do you remember the date? In the middle of May, second half of May. We'll see you in the second half of May in Positive Hug Days. And I hope that we will be able to see each other. We'll be able to see the results of our work. And of course, Vladimir Nazarov was with us, the head of the Department of the Security of Industrial Systems of Positive Technologies, which directly are connected to us. And I promise to all of you that in May, we will see 2 new sections at our 2 new cells in our little city, and you can roll back my broadcasting and you will see where they're going to be installed. Yes, thank you very much. control systems. Please don't switch off, because next will be an interesting conversation. See you.